Hello everybody, my name is Jerry and I have an awesome update on the Gravity Electric project. We're going to go ahead and purchase a mill so that we can machine the parts ourselves and get this project going. I'm really excited. It's been a long time coming. So stick with me because I got the details on everything that we're going to do coming up right now. So one of the things we have to overcome is turning that large piece of diameter tubing back there so they can fit into these bearings. So that's going to be one of the first things we do now. Normally this would be done on a lathe, but we really can't afford both the mill and the lathe. So there are ways to do it on the mill. So we're going to make an attempt to go ahead and turn down that piece on a mill very carefully. But I'm pretty sure we can get it done. So that's going to be one of the first things we do, because this particular piece of material right here is going to be our axle for the winding wheel. So I know I talked about that before, but now we actually have a means to, or at least we have a plan to go ahead and turn this down so it'll fit inside these bearings. Okay. Okay, I'm sure some of you remember, but for those that are new to the channel, this is the gearbox, which will be driven by sprockets. Now you can see the holes in the gearbox there, and in the front, so there'll be 3 different axles. And we got a bearing set up and some other things going in there for chain tensioners. And over here is the actual permanent magnet alternator, which actually would generate the electricity. Okay, so you'd have a sprocket there, an axle there, and there, and you have a massive gear amplification or magnification instead of reduction. So in this project, the gearing's being increased, not decreased. So, but however, since we have a mill, since we're getting the mill, we're not going to be using sprockets anymore. We're going to go ahead and create our own gear, make our own gears on the mill. Right? We're going to cut our own gears. That's what I'm trying to say. We're going to cut our own gears. Okay. So that's going to be really, really awesome, because it's going to reduce the footprint of this gearbox significantly. Be a much smaller gearbox. And I have some ideas about how some things may significantly change with this project and the device itself. So it may be much smaller than we originally planned, which is a good thing. Okay, now I'm going to show you some of the components that we're thinking about getting, some of the equipment. Now, the mill you see in front of you is a pretty decent sized mill. It's a little over 1 horsepower. It's kind of on the expensive side. We haven't really made the decision about what mill we're going to purchase yet, but this could be this is one of the mills we're looking at. So this has DRO, which you see the screen on the right. That's just digital readout in all 3 axes: the X, the Y, and the Z. So for those who don't know, X would be left and right, Y would be towards you and away from you, and Z would be up and down vertically. Okay, there's a lot of different features. Now this is not CNC enabled. This would just be you're turning the handles manually. But there are a lot of good things about that mill that are a step up from, let's say, a mini mill. Okay. All right, now let's move on to another mill. This is a smaller mill. This would be called a mini mill. And this one's the X2D. Now, this one I looked at over at the, I think it's littlemachineshop.com. This mill has been purchased by literally thousands, probably hundreds of maybe even thousands of people. Very reliable. It's a little bit on the small side. I think the motor is a third or a half horsepower, and but there are a lot of cool features about this mini mill compared to other mini mills. So that may be the way we go. Just depends on how much money is available when we actually get down to making the purchase. Okay, so this component you see in front of you would be the belt drive. The little mini mill that we just showed, it has gears, plastic gears as a matter of fact, and they notoriously break if you ever jam an end mill into a workpiece. Eventually you strip out the gears. So an upgrade to that would be this belt system, which is fairly inexpensive. I can't remember how much it is, maybe $60 or something. So it's well worth it to go ahead and upgrade to the belt system because you're not going to break any gears. So that's something we're looking at. The installation's pretty quick. I saw a YouTube video where a couple guys do the installation, and I don't think it's more than maybe a half an hour to an hour at the most, and that's if you're taking your time. So that's pretty certain we'd purchase that if we go with the mini mill. Okay, the next thing we're going to look at is some collets. Now, both the mills that we looked at so far are called have an R8 spindle, which is very common spindle here in the United States. That spindle was born out of the knee mills way back in the day, so which are still very good to this day. I mean, some of the knee mills back in the 40s and 50s and 60s are still really good machines. So anyway, these are collets, and you can see the various sizes here from 1/8 all the way up to probably 3/4 of an inch, incrementing by 1/16 of an inch at a time. Basically, these would hold your end mill, and you pull one out, put another one in, and you just have your end mill already in the collet and ready to go. Probably just sitting in a stand. Or if you're really fancy, you could have an automatic tool changer, which would be cool. But for where we're going initially, we probably wouldn't have the automatic tool changer just because of budget. Okay, so the next thing we're going to look at here is this is Tormac's. Tormac is a company that makes a nice, decent mill, kind of a semi-production mill. And they have this thing called TTS, a TTS system. And this is the TTS adapter that goes into the R8 mill, and then you can use all of their collets, I think, or maybe they're called. I think they might be called end mill holders. Yeah, they're called end mill holders. So you put this into your mill first, and then your end mill holder goes into that. And the cool thing about that TTS setup from Tormac is your Z-axis doesn't change. So if you already done your measurements and got everything in order and you're ready to go ahead and make your cuts on your workpiece, very convenient to not have to recalibrate in the Z-axis. So that's one cool feature about the TTS system. And this would be the actual end mill holder for the Tormac TTS system. Now, I'm just showing you one of them. They come in different sizes from like 1/8 of an inch up to a 1/2 inch or even larger. Okay, the next thing we're looking at here is these are the feed screw. So for the mini mill, the little tiny red one that I showed, this would be an upgrade called a feed screw. It's 20 TPI, 20 turns per inch. I think it's TPI turns per inch. So the convenience for that is it's very easy to calculate at 20 TPI. Some of these, most of these mini mills, the turn per handle is not very intuitive on how you calculate the amount of feed you have when you're turning the handle. So this upgrade is fairly inexpensive. I don't remember how much it is, but again, 50 or 60 bucks, well worth money well spent. And you can see the little dials up there. The increments are, I think, 1/1000th of an inch each. So very, very convenient, much easier to calculate with this upgrade. Okay, the next thing we're looking at here is these are the actual end mills. Now, initially, we just probably get about 20 end mills from like a 1/16 up to 3/4. And these are just high speed steel, I think with titanium, a titanium tip, titanium coated tip. Ideally you'd want carbide, so no matter what you're going after, no matter what your workpiece that you have, you're not going to have any issues. But the carbide's pretty expensive, so for us initially we're going to just go with some high speed steel. We'll see how it works out. We are going to be cutting some carbon steel, maybe a little bit of aluminum too. We'll just see. But so hopefully these high speed steel titanium tipped end mills do the job. If not, then we'll have to upgrade and go with probably go with carbide if necessary. Okay, the next thing we're going to look at is this is called a rotary table. And there's two different types of tables. There's a rotary table and an indexer. They're not the same. But this rotary table, this is, now we may not be using this exact table. I'm just throwing in a picture here. But this would sit on the table of the mill. and then that tube I showed you earlier, we would turn it with something like this. We'd put it on it. We'd have to find out how to adapt it to this, but should be doable. And get it mounted onto the rotary table, and then have the mill turn down that workpiece. We only need to turn down the workpiece about 1 or 2 inches on each side, maybe 3 inches on each side, and we only need to turn it down for about 1/1000th to maybe 3/1000. So we don't have to turn it down too much, just enough to get it inside the bearings. So okay, anyway, I hope you all enjoyed the video. Make sure you subscribe to my YouTube channel. Make sure you click the notification bell while you're at it, because I know you're going to be really excited about where this project is headed. And stay tuned for more updates as we get this mill in. Hopefully we're going to get the mill in the next maybe 3 or 4 weeks. It all depends. It could take a little while after we order. It depends on how long it takes to ship. So, all right, talk to you all again real soon. Bye-bye.